My name is Ben Newell. I'm president of Build Equinox, and today's webinar will be covering our CERV2 Smart Ventilation System. This is an outline of what we'll be covering today. First, I'll do a general overview of what smart ventilation is, look at configuration, installation, operation of the CERV2 system, some performance features and options, and then some future tech. Feel free to submit questions anytime during the talk. I'll try to keep an eye on that as they pop up and address them as we go along here. So smart ventilation is going beyond current ventilation standards. A lot of you have probably heard of ASHRAE 62.2. This is the residential building standard. And an important note on ASHRAE 62.2 is that it's a minimum ventilation standard, but it's not an indoor air quality standard by any means. It has several limitations, including the requirements are based on historic odor detection studies, so not actual air quality metrics. It leads to a nominal airflow rate of about 15 to 20 CFM per person, which will result in greater than 1,000 parts per million of CO2 concentration within a space, which is starting to get towards an unacceptable level of CO2 concentration. It doesn't account for higher pollution events or occupancy changes. Homes are ever changing in these things. They're spaces that are very unpredictable. So these standards don't account for those things. Gas and electric appliances are treated the same way. And then, as I mentioned with the CO2 concentration, the standard's inadequate to avoid reductions in occupant health, cognition, sleep quality. These things are greatly impacted at levels of 1,000 or more CO2 concentration. So we can definitely do better than the minimal standards. So that brings us to smart ventilation. Smart ventilation, as we've defined it, is measuring pollutants and comfort conditions, and then a system will make operational decisions based on these data as well as user inputs. You can't control if you're not measuring things. This is the only way to ensure healthy and comfortable environment if you know the data. And then you can account for these differences in occupancy, different living activities going on, materials, building products, cleaning products, these things that impact the pollutant levels in a home, infiltration rate. And then besides giving you superior air quality, you can also optimize for energy as well. Now, CERV Smart Ventilation, more specifically then, what does the CERV do to lead to better air quality? The CERV measures indoor and outdoor temperature and relative humidity. And then inside, it's measuring carbon dioxide and volatile organic compound measurements. The graphic on the right is a screenshot of the touch screen built into the unit. So you can see the indoor and outdoor levels, and then the CO2 VOC pollutant levels in parts per million. The sensors are going to sense air quality before you do. So CO2 is something you normally can't detect poor levels of until it's extremely high, when you might have headaches or feel stuffiness. But reductions in health and cognition, sleep quality, those happen way before you're going to detect high levels of CO2. So that's why it's important to measure it specifically. VOC is something else that the sensors are going to sense most likely before you will. So by the time you can smell high VOCs, most likely they're going to be way out of range. But each compound is different. Some VOCs you're going to smell at levels that are actually harmless, as opposed to ones that you can't detect that may be at a concentration that are harmful. Then the system, by using these inputs, can adjust for different activity levels, different infiltration rates due to either leakiness in the home or doors and windows being opened and closed. You can set the CERV to optimize for energy conservation, which it's doing automatically. And then by recording this data, we can use these to, with different metrics and analytics, to provide feedback to the user. So you can see over time, how is the performance of your house? You can see if there's any issues. That way, do you need to make adjustments? Or do certain activities or other things in your home, how are those impacting your air quality? These trends show traditional ERV air quality levels versus a smart CERV smart system. The top one, then, you can see this is over time, the CO2 and VOC levels. This is for an actual high performance home where the air quality was monitored. And when the people were there, on the left side of the graph, you can see that's when they have the highest pollutant levels. And then it drops well below that when they were gone for a period of time. I think this is over a period of a week. So those several days, the system's still operating at the same ventilation rate, but the levels are so low you don't actually need to continue ventilating. And then when they come back, the levels then exceed the set point again, where you'd really want to maintain air quality levels. So it's inadequate ventilation when it's occupied, and then it's over-ventilating when nobody's there. Comparing that to trends taken from a CERV system with the set point set at the same level, as you hit that set point, that green background in these charts show when the CERV was ventilating. It hits a set point, brings it below that, and you can see it continues to ventilate as it's at that set point, and then as the occupancy or whatever other activities dissipate, then it no longer needs to maintain that same level of ventilation. So it's automatically adjusting to occupancy or activity levels and optimizing both air quality as well as the energy. Some other aspects of the CERV system are the superior filtration. We have large filter area, which reduces the pressure loss across the filters. So that allows the system to utilize high MERV level filtrations. We'll talk about that a bit later, but the standard MERV rating for the CERV is 13. Recirculation is another function the CERV can perform. This unifies the air quality and comfort throughout the home. It helps with additional filtration, so you can cut off particulates being brought in from the outside, and you can scrub those from the indoor levels to reduce the particulate level even further. And then you can make use of stored fresh air. So unoccupied rooms in the home hold fresh air that you can utilize in the recirculation manner. So that will delay needing to ventilate, helping conserve energy. And then the smart controls allows the CERV to interact with external devices. So outputs and inputs, functions such as zone dampering to control airflow. We'll look at these options later. And then the online connectivity I had mentioned, recording that data allows the system to provide user feedback, and you can look at historical data for the home to tell what's been going on over time. Some other impacts of smart ventilation going above and beyond the minimal air quality standards. People build high performance homes to improve comfort, save energy, increase the durability of a home, reduce the life cycle cost, and make homes more marketable. Smart ventilation then allows people to do those same things with a home, but you can also improve the health of the occupants, increase cognition, productivity of the occupants, improve their sleep quality, and then you can provide proof of a home's indoor air quality performance. So while you get a utility bill for a home that can show that it's low energy or net zero or that, recording the data and having the proof that you're able to maintain a home at a certain level then will result in it being more marketable and more attractive. Taking a look at energy versus the health perspective, and with the recent COVID-19 pandemic, we see how great an airborne virus, its impact can be on the economics of the country. But in terms of historic, more, I guess, common annual energy versus health impacts, if all the homes in the US, all 100 million homes in the US were high performance homes, it would be about $160 billion per year worth of energy to maintain them in terms of heating and cooling. So about 80 billion for the people loads and 80 billion of that for the climate. The assumptions here are 4,000 kilowatt hours per year per person, 12 cents per kilowatt hour, 325 million people. But if we look at the historic annual cost of seasonal influenza, that was 87 billion. So half of the energy cost per year for high performance homes. We're already at that kind of a level that we spend per year just to fight the flu. Improved ventilation rates reduces contagion concentrations, so you can really reduce the percentage of people that are going to be affected by the flu and colds. So you can really see that you can take a big chunk out of that cost in terms of related to energy. Asthma is another big one. About 10% of the population is affected by asthma now, about a third of households. This is another $56 billion per year. Can we reduce that to historic levels where we were about 5% of the populace affected by asthma? Or can we do even better? So that's another big chunk. Compare those two things to the annual energy. That's significant. And then there's improving cognition and productivity. The $50,000 a year job, if you can increase productivity by 1%, that's $500 a year. So that's, is that 10% productivity you can increase with better air quality levels? And that's a significant amount of income for somebody. What other things are you affecting with lower cognition in a house or poor sleep quality? These things translate into homework or tests or job performance. So not just things in your house, but things that impact you outside of your home as well. So that's where smart ventilation really has a broad reach economically as well as health-wise. Looking specifically then at the CERV2 system, we'll start looking at the configuration and operation of the unit. The CERV2 is our second generation unit, so it's an all-in-one. The heat pump and the dampers used for the air control, as well as the fans, are all built within the unit itself. Our previous generation unit was more modular, where things were done outside of a single unit. So this significantly has improved the installation ease. There's an integrated touchscreen color display. The housing is a sleek all aluminum unpainted construction, so it has a stainless steel high quality look to it, and that also makes it more recyclable. The connections are all 8-inch, so these are nice large duct connections to reduce pressure loss, reduce any noise, trying to keep airflow noise down, reducing fan power as well. And then on the CERV2, we've expanded the capabilities from an I/O input-output standpoint, so interacting with outside devices and capabilities. The CERV does energy recovery through a heat pump system. We use a digitally controlled inverter drive compressor, so we can change the speeds to match the loads and optimize for energy efficiency. An electronic expansion valve also gives us some of that improved capacity control and efficiency. We use lightweight aluminum microchannel heat exchangers. These are, so it's an all metal heat exchanger construction. This has reduced our refrigerant charge and also has nice low pressure drop characteristics on the air side to reduce that fan power. The configuration of the system is shown here. There's the 4 duct connections like you'd find on a conventional ERV or HRV system. The 2 inlets into the system are the fresh air from outside, and then the return duct from the house. And then the outlet ducts are located in the back. So there's a supply duct to the house and then an exhaust duct to the outside. The unit just plugs into a standard 120 outlet. Condensate drain is located in the rear of the unit there. The color touchscreen I mentioned is in the front, and then the controls in that are located in the front as well. This shows kind of the general footprint of the unit and the size requirements. There's not much clearance needed on the sides or back and front of the unit. The top of the unit is where the filter access is located, so you do need some room there to either pull the filters out vertically. That head height can be lower than what's shown here, that 62 inches, as if you have more access from the side of the unit where you can remove the filters in a more of a horizontal fashion. This is just a close-up of the display, so it's a nice large 3.5-inch capacitive touchscreen display. We also have a wireless controller as an option as well. So if you wanted a dedicated control somewhere else in the house, this can be added on as an option. The unit also has Wi-Fi built into it, so a lot of people just use the apps to control their unit and view data online that way. The installation, I mentioned, it just plugs into an outlet. The unit can be just set on the floor, built a platform if you want to maintain some storage space below it. But really you're just making the 4 duct connections, connecting condensate drain to either a pump or you can run just to a floor drain as well. Most common space that you would install the unit if you have a basement or a mechanical room in the house. Some are put into attic spaces. The unit does need to go into climate controlled, so anywhere from 50 to 80 degrees Fahrenheit. You don't want to have freeze up issues with the condensate, or if you get much out of that range, then that affects the efficiency and performance as well. So making sure it's within the conditioned envelope is important. Here's a picture of a typical installation. The condensate drain shown here is an old style, so that has actually been moved to the rear of the system. But you can see the 4 ducts just coming in from the top, labeled here on the schematic to the left. So that filter access panel comes out and you see the fresh air filter and then the return air filter are just side by side there. The supply to the house and then the return air from the house, those can be uninsulated. And then it's important to have good insulation on the ducts, the fresh air coming from outside and then the exhaust to the outside, as you don't want to develop any sweating or frost on those ducts that can create moisture issues. But a typical install of the actual unit, assuming the ducting is already in place, is probably on the order of just an hour or so. So it's fairly simple to install the actual system. The ducting scheme that we recommend is to pull exhaust or returns back to the CERV from bathrooms, kitchen, laundry, mud rooms, any areas where odors and moisture are going to be produced. So to extract those pollutants from the house, and then supplying the fresh air to bedrooms and living spaces. The unit can also be ducted to a central air handler. So if you have a central furnace, geothermal air conditioning system, you can connect the return and supply side from the CERV to that system. Or if you will be handling spot ventilation through the CERV from bathrooms and kitchen areas, you would need dedicated ducting to those locations, but you could still supply the fresh air to a central system to distribute that throughout the home. The nominal airflow rate of the CERV is 100 to 300 CFM, and the fans are variable speed, so you can set it according to the house side or occupancy levels or whatever. And then some guidelines just on the ducting. Aiming for a static pressure of 0.2 is ideal. Going a bit above there is okay too, but you want the fans to run at kind of an intermediate speed, so you do have some room to compensate for the installation. And then trying to maintain an air velocity of 300 to 400 feet per minute will result in nice quiet airflow, low fan power. Typically, for dedicated ducts, they're going to run from 8 inches down to 4 inches throughout the home. And then trying to utilize rigid duct as much as possible, flex duct in strategic locations, but it's fine to use if installed properly. Some people have used other ducting mechanisms as well. So there's where you can buy those small diameter flexible ducts. Those are fine. They're typically pretty expensive. They aren't as easy to install as you might think. And then they limit the airflow as well. So it's something to think about, but that can be an option. Someone had asked then what the utility ducts are for. Those are actually not included in the CERV anymore. Those were for pulling from utility spaces, so like a heat pump water heater or a laundry space. But we've since removed those and just recommend adding conventional return back to the system like you would in other parts of the house. So we had those offset, just thinking that if there were temperature gradients between where the CERV is located in those spaces, that offsetting them from where the temperature readings are taken may help, but we haven't seen that as an issue, so we've just eliminated those from the current system. In terms of the operation, this shows all of the different operating modes possible with the CERV. So in ventilation, using energy recovery as well as a heat pump, you get ventilation, heating, and cooling modes. You can also, the system can keep the heat pump off. So if all the other set points are satisfied, but you need fresh air, you just bring the fresh air in without the heat pump running. So you can do free heating and free cooling in that manner. You may see that a lot of times in the swing seasons. So if the house is needs cooling and it's nice and cool outside, you can just bring that nice cool air in. Energy recovery isn't beneficial at that point. So that would be free heating or free cooling modes of operation. If air quality is satisfied, the system can use the heat pump to add supplemental heating or cooling to the house. You don't want to rely on this to fully condition the house, so you do need a primary heating or cooling source. But for low load homes in moderate climates, the CERV may do a significant amount of the heating or cooling needed, especially in the swing seasons. So that's what the recirculation heating and recirculation cooling modes are for. Dehumidification is part of the cooling mode. So like a conventional air conditioner does some latent along with a sensible, the CERV does the same thing. And then just the recirculation mixing then, along with the recirculation heating or cooling, that allows a system to do additional filtration of the indoor air without introducing particulates from the outside. And then if all the set points are satisfied, then the system can just go off, and then it periodically comes on to do an assessment to see if it needs to make any adjustments. So it will switch between all these modes automatically based on the current readings as well as the user set points. The kind of the modes of operation are shown here in the schematics on the right-hand side. So there's the dampers are going to move in different modes of operation, giving you that recirculation versus the ventilation modes. Now these dampers are different than the zone dampers that we'll talk about later in the talk. The internal ones are the ones dictating these different modes of operation, where the zone dampers are something external that this system can use to optimize spot ventilation. In terms of what the system is monitoring, we had talked about that a little bit before, but the indoor air quality, measuring independent CO2 and VOC readings, and then temperature and humidity levels, both for indoor versus outdoor levels. We also have the capability to add sensors to the fresh air stream as well. This is something we're still looking at. A lot of our users in locations where wildfires are a concern, being able to detect when outdoor air quality is not optimal to bring inside is something that's important. So do you change your filtration level? Do you change your how the system operates in terms of bringing fresh air in? These are things we can do by sensing the outdoor air quality as well as the indoor air quality. So a lot of our, if you can get in a situation where bringing that outdoor air inside can raise your pollutant levels. So in a way, it's giving you a false sense of what's going on inside. So being able to isolate that and determine that, hey, these are things coming from outside as opposed to inside, can then let you make adjustments, or the system can adjust those itself. So these are things we're still looking at. But the nice thing with the CERV having online connectivity is that we can do these over-the-air updates. So if you buy a system today, it will just get better with time. So you can make use of these different functionalities as they come into play. The control screen, this is the one built into the unit, but it's the same controller that you would see online with the app, or if you have the wireless controller as an option. The home screen here shows the current status. The house icon is above the current indoor temperature and humidity levels. The cloud is the outdoor temperature and humidity. And then the CO2 and VOC levels are shown in parts per million. VOCs are generally measured in parts per billion, but we've used a sensor that is correlated to the human generation of CO2 in parts per million. And this way they can show the same scale. If you're seeing CO2 and VOC levels traced together, then it's most likely an indication that you just have human generated VOCs. If you see higher VOC levels, then you are going to be having additional sources of VOCs. These are also total VOCs, so it's not necessarily an indication that they're VOCs from something good or something bad. It can be from cooking or things like that, chicken noodle soup, which may be good VOC levels, versus cleaning products or building materials or other pollutants that may be harmful. So that's an important distinction, that it's looking at total VOC, so it's not necessarily indicating that it's something bad and detrimental to your health, but just giving you an indication of what's in your air. This is how the set points are going to be set on the unit. So pressing on the CO2 VOC cloud area, the user can set the CO2 VOC level in parts per million. Generally, 800 to 1100 parts per million is where this is set. 800 ppm and less is a good air quality level. So if your system is triggering based on kind of that range, on average, you should, with unoccupied versus occupied times, you should have average levels that are well below the set point. You can also set a scheduled ventilation on top of that. So if you want a base level of fresh air brought into the house, you can set a percentage out of every hour that the system will bring fresh air in, no matter what the air quality levels may be. And then you're also going to be setting the heating and cooling set points. This will dictate kind of those heating and cooling modes of operation that the system can do as well. So the recirculation heating, recirculation cooling, as well as the free heating and free cooling modes of operation. This is performance data that you can find on our website under specifications. So we just list the heating and cooling performance at different outdoor and indoor levels of operation. It's different than a conventional ERV or HRV. It doesn't have an effectiveness. Using the heat pump lets us go well above 100% effectiveness, where conventional systems are limited by basically 100%. Typically, they are going to operate 60 to 80% effectiveness, so we can go well above that. The goal of the CERV is to introduce the fresh air into the house in a conditioned state. So then you won't have to do any further heating or cooling of that air. It will be supplied to the house, if at all possible, in that manner. And then the recirculation mode is important, that it can further then, when fresh air isn't needed, contribute to the comfort of the home in that way as well. The fans are very efficient as well. They're variable speed ECM. So typically the fans are going to be running at about 3 watts or 3 CFM per watt for typical operation. That will be determined on the ducting as well. So making sure to have good duct design and installation is important, as it is with any type of system. This is just a fan curve showing, this is actually our first generation versus the second generation CERV2. So we made some improvements that way in the design. The solid lines are the first generation unit and the dotted lines are the second. So at each static pressure, we're getting a lot more airflow than we were before at different fan speeds. The shaded blue region is kind of the typical recommended static pressure for ducts. So being within that 0.1 to 0.4 inches of static pressure is going to lead to good system performance in terms of airflow rate. There's two, I should mention there are two options available with the CERV. The previous graph was for our 6EC model, and then this is for the 8EC that has larger fans built within it. Everything else on the unit is identical, it's just different fans. So the smaller one is typical for houses that are 1,000 to 1,200 square feet or less, or where you may be ducting it to a central air handler and you don't really need the static pressure capability. And then the larger fan, the 6EC model, can go up to 3,000 to 4,000 square foot home. Both having a nominal airflow range of 100 to 300 CFM. This is a COP performance level of the first generation versus second generation. This is the recirculation heating efficiency. So we've increased the performance across the board of the COP of about 1, better than it was previously. And to do that, we optimize the system a little bit with the components as well as the algorithms within it. We sacrifice a little bit of higher temperature heating capacity to gain some lower, and that also increased our COP levels. But this shows kind of the typical heating capacity and recirculation across different outdoor temperatures. We'll look here at then the specific features and options of the system. Filtration is just a really important aspect of a smart ventilation system. MERV 13 filters are our standard filter rating for the CERV filters. They are common 10-inch by 20-inch by 1-inch filters, so you can find them almost anywhere. You can use a 2-inch depth filter as well, or stack multiple 1-inch filters to give you different filter characteristics. There's 2 filters built into the system, as we saw earlier. There's one filtering the fresh air from outside, and then the other one is filtering the return air. So they're both protecting the system from buildup, as well as filtering the air that's supplied into the house. The OEM filters that we offer in our filter store, we try to keep filter cost as low as possible. So that's another reason why we use, they're not proprietary filters in any way, but we want to encourage filter changes, both to, for better air quality inside the house, as well as protecting the system. So that was important to us in doing the design. And then we offer a lot of different filter options. So just the standard high MERV rated filters, also the carbon infused filters to help remove odors and VOCs. Where wildfires and that are a concern, these are fairly popular. And then a new filter we released about a year or so ago in partnership with a local company here. These are color fill filters. So they have even higher removal rates of typical household odors and VOCs, but they also change color as they absorb them, so you know when to change them. So this can give you an indication of how high your VOC levels are if you're having to change these fairly frequently, that you have high levels of typical VOCs in the house. Whereas if they go a long time between changing, then you know you have low occurrence of these types of VOCs. And then the system has filter reminders built in it, so you can change them according to your preference. Typical recommendation is not going longer than 3 months between filter changes, but you may find you need to change the outdoor filter monthly, while the indoor return filter maybe is okay at that 3-month interval, but you can set these accordingly. The communication built into the unit is both Wi-Fi, so that connects online to the internet, and then N-Ocean is another wireless communication built into it. This is a low power wireless communication used for some of our wireless options that go along with the CERV. The service is what we call our online interface and control. So this is free to use. So all you have to do is connect your unit online, and you can use that as long as you have internet connection. This allows you software grades that I mentioned. And then we have an app both with Apple as well as Android devices. So it's just a free app you can use. If you don't have a CERV and want to check that out, you can still download it, and you can actually view data from a real CERV online just to see that interface for yourself. The controller online is the same as it is built into the unit, so this just makes it easy to use. But you can use this on a phone, iPad, computer, laptop, whatever device you like. So most of our customers, this is how they access control to their unit. So you don't have to go to the unit, and you can check in on it remotely as well. So if you're not at home, you can make adjustments to the system while you're gone. The historic data then, that'll show you both air quality data as well as temperature and humidity data for the unit. And then the analytics page, this gives you feedback using different metrics on your house. You both get, these are kind of in monthly and weekly increments, both for your home, and it also compares you to the CERV community as a whole. So you can see how you're doing compared to other users. But the main metrics here are looking at how your health, your cognition, sleep quality, based on your pollutant levels, how these are compared to what they would have been just ventilating to the ASHRAE 62.2 standards. So in this case, you see doing 78% better compared to health, 84% better compared to cognition, and then sleep quality as well. Pollutant exposure time, that's looking at CO2 relative to VOCs, letting you know which way your home may be skewed that way. And then your exposure over the course of a day. So what level are you exposed to these pollutants over the course of a day? This can give you more indication of how your house is doing over time and how often or how much you're exposed to these pollutants. We have another webinar called IAQ Metrics that goes more in depth to these things, so that may be of interest to you. You can find that on our website or YouTube channel. The communication to the outside, the Wi-Fi, obviously that's for doing the online control and monitoring. And then there's both wired inputs and outputs. So these are where the CERV would be detecting an input from an external device to tell it to do something. And then the outputs are things that the CERV can tell other devices to do based on its readings. And then the wireless devices that I mentioned using that N-Ocean protocol. The wired inputs then built into the unit, there's one output channel. It's either dry contact or 24-volt output. And then there's one input channel built in as well. So that's dry contact or 24-volt sense. So it's a flexible standard communication to the outside. We have an expansion board then that can add 3 additional input channels and 6 output channels. So if you have multiple devices needing communication. This shows what you can do with those inputs. So the functionality for the inputs are you can do ventilation, you can do heating, you can do cooling, you can force the unit to recirculate, or you can halt operation. So these are triggers from external devices and you want to tell the CERV to do something specific based on whatever, these are the things giving you that sort of capability. Probably the most common thing used here would be the halt operation connected to something like a moisture sensor. So if there was a blockage in the condensate line and moisture detected, you can tell the system to just stop operating. Some people also use that halt operation for window and door opening. So if it's nice outside and you just want to open windows, you can automatically tell the system to just stay off while you have that open. The outputs are things where the CERV's using its internal measurements and readings and control to do things externally. So with this, you can do heating and cooling, ventilation, you have fan interlock, you can control humidification, dehumidification. GeoBoost is a ground loop heat exchanger we offer to precondition the air going to the CERV. So this increases its efficiency and capacity during extreme conditions. So you can kind of preheat or pre-cool the air. With that, it would connect to a geothermal unit if you have that, or you can just use a shallow horizontal well with that as well. And then our zone dampers, probably the most common option that people use with the output channels. Wireless devices, the wireless switches are the most common thing. This is for triggering spot ventilation. So we have wall switches as well as active circuit transmitters. The wall switch is just like a bathroom vent fan you might have in your house right now. So you hit this switch and that will tell the CERV to start ventilating. The active circuit transmitters wire to an electric circuit like a light or a vent hood, and that also can trigger the CERV to do something like start ventilating when the kitchen hood is on or when a certain light is on. We have remote sensors for temperature, humidity, CO2. Right now, those can just be paired for external device control, but coming here soon that we can use those same remote sensors to tell the CERV internally to do things as well. And then like the wired output channels, we have wireless relays, so the CERV can control things wirelessly as well. Closer look at the remote venting. This is by far the most popular option with the CERV, just the bathroom, kitchen spot ventilation switches. With these then, that Anocean low power wireless communication, the switches then you set a ventilation time length, and then you can also have a custom fan speed as well. The active circuit transmitters operate in a similar fashion. And then you can name these uniquely, so you can have a different fan speed and vent length for a half bath versus a full bathroom versus the master bathroom. So you have nice flexibility here. The wall switches are nice because they're wireless. They're also battery free, so you don't have to replace a battery. Pressing the switch is enough power to generate the signal that's sent to the CERV, so you can place these anywhere in your house without having to add any wiring. Zone dampers can be layered on top of the wireless switches and active circuit transmitters. So this allows you to do more precise control of spot ventilation. So if you link the master bathroom switch, if there's zone dampers, then when that switch is pressed, the CERV will pull more air specifically from that zone, calling for ventilation. So that's really powerful in being able to target ventilation from zones where the pollutants are being generated. So in homes where spot ventilation, especially for larger homes where you may have multiple bathrooms and the kitchen and other spaces to ventilate, where for normal operation, those spaces don't need as high of an airflow rate. But for spot ventilation, when someone's actively using them and you need higher airflow, then it allows a system to pull higher air from those to meet codes and do that more effectively. But again, you can you'll set the time length and fan speed, and then you would link a zone to these specifically. So these are a really powerful option that the CERV can do. Our most recent option, and it happened to coincide with the renewed interest in UV from COVID-19, is our CERV UV. This is ultraviolet germicidal irradiation, so we can actively kill microbes in the air and on surfaces within the CERV system. So these microbes contribute to poor air quality levels, disease transmission, so colds and viruses, those things can be killed. But there are also things that can impact system efficiency. So using UV internally then can actively kill things from surfaces. This is an advantage on the CERV that no other system can utilize. Conventional ERVs and HRVs use plastic heat exchange cores for the most part, which would just be completely destroyed by adding UV light to them. So this is a unique feature that the CERV can offer. But the light source is an 18-watt light source. The nominal wavelength is 250 to 260 UVC. There's no ozone production with this, which is important. And it has a single pass kill efficiency of 85%. So we've tuned this specifically for the CERV's operation and airflow characteristics to ensure it has good effectiveness. And then built into the unit, then it keeps track of the runtime hours. So you get about a year per lamp on these before you need to replace them to maintain that effectiveness. And then we continue to develop different capabilities and features as well. So right now we are working on smart home integration. We currently have mini split control. So we do have a ductless mini split controller where the CERV can control those remotely. And coming out here shortly, we also have ducted mini split integration. If you get our newsletter, we've released some information on that, but this integrates a ducted mini split with the CERV to increase the heating and cooling capacity of the unit. So this is a powerful kind of all-in-one integration to really give you that optimized heating, cooling, and ventilation all-in-one package. And we'll be releasing more of that information here in the near future. So that does it in terms of this webinar. Looks like we have a few minutes here. If there's any specific questions I can answer. Signing up from our newsletter is a good way to kind of stay up to date on new releases and different topics, education and other. You can find these on our website as well under news that we have our past newsletter articles and webinars and other items that way. And of course, contact us anytime with questions or more information. Let me just see what kind of questions we may have coming in here. I tried to get to a few of these as we were going through the webinar. In terms of using the zoning for different applications, the zoning is used to really tune for optimizing that spot ventilation that I mentioned. It's not utilized to pull air specifically from a location where it may be more beneficial in terms of thermal needs and system efficiency. So if you wanted to pull air from somewhere more beneficial, you could, that is more along the lines of our GeoBoost system. So you could use that functionality along with dampers to, the system automatically assesses that source and it can pull air from those when it is beneficial, and otherwise it could tune those out. So earth tube is another example where you could, the CERV can automatically look at where it wants to pull air from and pull it from a more thermally advantageous space. The airflow rate on the CERV is that 100 to 300 nominal airflow. That's both for recirculation mode as well as the ventilation mode. And then the different triggers can be used to boost that up. So your nominal rate may be like 150 CFM just for normal operation, ventilation because of high pollutant levels. And then you may boost that up to 200 or 250 CFM when a bathroom or kitchen is calling for ventilation. So that's the full, the dampers switching between the recirculation and ventilation, that same airflow rate is maintained between those different modes of operation. So it looks like those are all the questions for now. As I mentioned, feel free to contact us at any time for any other questions. And thanks again for joining us here.